Okay, going to look at expanding brackets. Expanding brackets, good way to finish off this chunk of algebra. It doesn't use anything that we haven't done, but it's got a little bit going on. So we've got, when we're dealing with brackets, try and keep my hand out of the way, there's an unspoken times there. And the 6, which is outside the bracket, it's multiplied by any terms that are inside the bracket. Terms we can spot because they're separated by a plus or a minus. I sometimes do like a whisker for each multiplication. So the 6 has to be times by 2x, and separately the 6 has to be times by -3. And I can write it the long way if I want. I wouldn't normally bother with this. I would normally go straight to this line I'm about to write down. 6 2s are 12, so I've got 12x. And 6 times -3 is -18. And that's what we call expanded. Now, if I've got something like this, which is a little bit messier, the same principle applies. There's unspoken times is there and there. Little bit, there's an unspoken 1 times there. Okay, so that's standard. We can set it up so the 4 has to be times by the x and the -5. -1 has to be times by the x and the +3. 2 has to be times by the x and +4. So if I do them all, I've got 4 times x, 4x. I'll do this the quick way this time. 4 times -5, -20. -1 times x is -x. I'll just leave it like that. -1 times +3 is -3. Now I'm dealing with the last bracket. 2 times x I write as 2x. 2 times +4 I write as just +8. And then, and this is something we've been doing anyway as well, we gather up any like terms. And so I've got 4x minus 1x plus another 2, so I've got 5x. And I've got -20 minus 3, which is -23 so far, plus 8, -15. The only thing that I could allow for perhaps is if I have something like this, x in a bracket, and I have x squared minus 4, say. And the same thing applies. There's an unspoken times there. There's 2 things to multiply. And now I've got x times x squared, so that's x times x times x, so that's x cubed. I've got x times -4, which I'd write as minus 4x. That's the tidiest way. So those power rules for indices, and there's an unspoken, I suppose, 1 there, x to the power of 1, those still apply as well. Okay.